The universe should not exist. And yet, here it is. Everything we see, stars, planets, people, should have been wiped out before it even began. At the very dawn of existence, the Big Bang brought into being equal amounts of matter and antimatter. But these two opposites, when they meet, annihilate each other completely. So how did anything survive this universal self-destruction? This question isn't just fascinating, it's one of the most profound mysteries in all of science. A riddle so fundamental that it shakes the foundations of our understanding of existence itself. Somehow, against all odds, our universe won a cosmic coin toss. Instead of collapsing back into nothing, it grew, expanded, and formed everything we know: galaxies, stars, planets, and life. Before we dive deeper, take a moment. Let us know in the comments where in the world you're watching from and what time it is. It helps connect us, not just through science, but as inhabitants of this miraculous, improbable cosmos. Music fades in, celestial and meditative. Now, let's settle in for a mind-expanding journey through time and space. The fact that the universe exists at all is not a trivial observation. It is, in fact, a question that pierces the heart of logic and physics. We find ourselves living in a cosmos of immense scale and incredible intricacy, a realm filled with billions of galaxies, each holding billions of stars and perhaps more planets than we could ever count. But most astonishingly, this universe has produced life, and even more curiously, conscious beings like us who can ask, why? This is not just a philosophical musing, it's a scientific dilemma. From a purely logical standpoint, nothingness is far more stable, more natural. The complete absence of matter, energy, space, time, even the physical laws themselves, seems like the cleanest state of all. Why then is there something instead of nothing? It's a puzzle that has haunted physicists, cosmologists, and philosophers alike. One of the first clues lies in the concept of symmetry. The laws of nature are known for their perfect balances: action and reaction, positive and negative, matter and antimatter. But what if, just what if, this symmetry wasn't quite perfect? When the universe first exploded into being, it was hot, dense, and incredibly chaotic. Energy condensed into particles, protons, electrons, neutrons, and their opposites, antiparticles. Theoretically, they should have canceled each other out perfectly. But in a stunning deviation from symmetry, there was a tiny imbalance, an extra particle of matter for every billion particle-antiparticle pairs. Just one in a billion. That single anomaly is the reason we exist. Everything, every mountain, tree, planet, and person is made from the leftover scraps of that ancient imbalance. Without it, the universe would be a void of pure light and radiation. No structure, no galaxies, no us. But this leads to a deeper question. Why did that imbalance occur? To understand that, scientists turn to powerful particle accelerators like the Large Hadron Collider. Smashing protons together at near light speed, they attempt to recreate the conditions just after the Big Bang, searching for evidence of processes that could favor matter over antimatter. Some intriguing clues have emerged. For example, certain types of subatomic particles, like kaons and b-mesons, have been observed to decay slightly more into matter than antimatter. This phenomenon, known as CP violation, suggests the universe doesn't treat matter and antimatter equally after all. Still, the level of imbalance we observe in these experiments is far too small to explain the massive dominance of matter in the universe today. It's as if the universe is holding back its full story, whispering part of the truth while keeping the rest locked behind cosmic curtains. Could there be other unknown forces at play? Perhaps an undiscovered particle that tipped the balance early on? Or maybe multiple universes exist, most annihilating themselves in symmetrical fury, while ours survived by sheer chance or through some deeper cosmic law. This is where cosmology begins to overlap with quantum theory, string theory, and even metaphysics. The deeper we dig, the more our reality seems to be constructed from probabilities rather than certainties. Some theories suggest that our universe is just one of countless others in a vast multiverse, each with its own laws, particles, and outcomes. And in this unimaginable ocean of universes, perhaps only a rare few had just the right conditions for matter to persist, for stars to form, and for life to emerge. We may be the product of a multiversal lottery. So again, we come back to that haunting question. Why something instead of nothing? Is it chance? A quirk of symmetry breaking? Or is there a deeper principle, perhaps not yet understood, that demands existence, complexity, and consciousness? What's truly awe-inspiring is that we're able to ask this question at all. From a tiny planet orbiting an ordinary star in a galaxy among billions, we've built tools, theories, and instruments capable of looking back almost to the beginning of time. And yet, the ultimate answer still eludes us. But maybe, just maybe, the mystery is part of the beauty, that in a universe governed by particles, probabilities, and paradoxes, the fact that we can wonder at all is proof that some cosmic miracle took place. So as we gaze into the heavens, seeking answers, let us also marvel at the question. Because in the end, the question itself, the pursuit of truth, wonder, and meaning, might be the most extraordinary thing the universe ever created.